Hello, welcome to Cup of Java Week 2, Python. Today we're going to be covering Python basics. So the first thing we're going to talk about are variables. So variables store information. So kind of like in math when we say like x equals 5, same thing with Python. So some things with Python syntax with variables, they're case sensitive. So if I write like lowercase x equals 5, and then I write uppercase x equals 2. X and x, like lowercase x and uppercase x, are two different variables, and Python will interpret them as two different variables. And you always have to start with a letter or the underscore character and not a number. And you can only contain alphanumeric characters, so you can contain numbers after the first character, and underscores. So this means no spaces. And they are created once you assign them a value using the assignment operator, which is the equal sign. So one of the things with Python is you don't have to like initiate your variables before you assign them a value. And there's no need to declare the variable type. So if you've like taken any of our Java courses, you may remember that we had to say like int x equals 5. But with Python, you can just say x equals 5. And Python will be able to tell, oh, this is an integer. And it's also pretty easy to change a data type with typecasting. So the next thing we'll talk about are inputs. So when we, interact with web applications or like apps or like mobile apps on our phones, or really like any sort of like software on our computers, there's sort of this like back and forth interaction between like us and the computer. So like we tell the computer to do something and it'll respond and like give us an output. So we talked about outputs last week with print statements like hello world, sort of like the intro to programming. And so now we're going to talk about inputs. So quite literally, this is going to be like how you tell the computer how to do, like tell the program to do something. And the program is going to take in what you tell it to do and it'll, based on that, react. So basically, for example, if we type here on the second line input and then in quotes enter a number, colon, and this will display, this is like our like terminal, enter a number, and then this is what it'll show the user, and then here it'll like prompt the user, it'll be like do something. So I'll give an example on Replit. If we just can create a Replit Python, we'll just call it that for now. It's loading. So last week we talked about working on the like idle shell and Python locally. Today we're going to try with Replit just because, to feel for it. Generally, Replit is very helpful when it comes to creating smaller like group projects because kind of like, in Google Docs, you can collaborate real time with other people. The only downside is Replit is a lot slower than if you run things locally. So if you're handling like big sets of data, you really want to, try and like use GitHub or something if you're going to collaborate. Okay, so let's say I want to do an input and what was it? You were asking for a number. So what I would do is, like we talked about, variables. So one thing with inputs is you input something and that what the user tells the computer, like what the user types out, that gets stored in sort of like your variable. And you generally want to hold on to what the user sort of like gives the computer so you can use it later on. So like, for example, I could do like x, so assignment operator equals, and then input plus enter a number. So one of the things that might be a little confusing here is how, so like last week we talked about print statements, and with print statements we said print enter a number. And so this line, I'll comment this out, remember it's a hashtag for a single line, just printed enter number, and then you see how like the cursor kind of just like the program ended. And so this quite literally just prints out enter number. And with inputs, so the input, what the quote is, it's not really the answer, it's the question. So you want to keep that in mind. So you can't like input a user's answer, if that makes sense. This part is just like what you're going to prompt the user to tell them what your question is for them to give you an answer. So like, comment this one out, input, enter a number. So now you see how it's like there, it hasn't like, I guess, moved on and quit. So like I can do 5 and now it's ending. And so now let's say I want to print out the variable x. So let's try it again. I say 5 and it'll print out 5 for me. So if we go back, right, you need to assign the input to a variable like we did here. And inputs always default to string, so you have to typecast to make the input a different data type. So like, let's say I have this, let's print type, if we remember, that's how we like tell type what data type x is. They'll say 5, and it's a class string. So in order to make this an int, we typecast, remember, we put the things around it, and then we print x again. We'll change the number up, let's say 10 this time. And now it'll show a class int. So you want to really be careful. We'll see later on in our project, but it's super duper important that you typecast integers if you want integers, like if you're going to use your numbers to do computation. So that's something to keep in mind. Next, math operators. So Python math is pretty similar to like regular math. So like addition is the addition symbol, subtraction is the subtraction symbol, multiplication is the little asterisk, division is the /, yeah. Modulus is the % sign. Exponentiation is 2 asterisks, and then floor division is the like a double of /. So floor division is kind of like goes with modulus, so like modulus is kind of like your remainder, and then floor division is sort of like the whole number you get, if that makes sense. We'll just like do a couple of examples here to like x, maybe we should change the variable name. So like y equals 3 plus 4, print y, ooh, something like that. Oh, we should probably comment this out, but like it'll print 7 because 3 plus 4 is 7. If let's say like we want to try like the modulus, yeah, I think that one's pretty, I guess that one's one of the different ones, like this. So 10 mod 4, so 10 divided by 4 gives us a remainder of 2, so we're expecting y to be 2. Oh, still forgot to comment that out. Yeah, so we get 2, and then we can try the like floor division. Before I forget, I'll just singles. You can remember do the like triple quote docstring, but I'm just gonna keep it as like hashtags, single line comments. But yeah, it'll print out 2. Oh, this is your remainder. So actually, I'm gonna change my example a little bit so we can see the difference. So this will print out 3 because 3 times 4 gives us 12, and then we have a remainder of 1. So like, oh, whoops. Something like that, and it'll give you 1. And yeah, that's pretty much with math operators. So next we're going to talk about import statements. So there's a lot more to math than just, the math operators we saw on the last slide. So one of the things we like to do, especially like kind of relating to import statements, is we want to import these modules or like libraries that will give us extra like capabilities so that we don't have to construct the code ourselves or like write it out. So specifically, a module is a file containing definitions and statements, so like more code. And you want to use any functions in a Python module, you have to import it. So at the very top of your code, like up here, like, well, sometimes good coding practice, you want to do like the docstring and you want to give a description of your code. So like, we'll go more into like this with our project, but like this is our description. And then right under it, you want to say import and then whatever. So we're going to import math. Okay, yeah. So yeah, imports should go to at the very top of the file. And so we have a math module. So like I was saying, math is more than just adding and subtracting, like basic arithmetic. So here are some of, the functions within the math module. So we have math.square root, that's just square root. Math.power, that's a value of x to the power of y. So that's kind of like the double asterisk, but this is just a different way to write it. Math.degrees, you convert an angle from radians to degrees. Math.e gives us Euler's number. Math.pi gives us pi. that sort of stuff. So there's two ways to import this. So if you want to import like an entire module, you say like import math. And then when you want to use a specific function, you have to say math.square root or like math.power or something. But let's say you know from the get-go that you're only going to use one function from the math module, then you don't have to import the entire module. What you do is you say from math import square root, or like from math import pi, something like that. And then you don't have to do the math dot because you've imported just like the function alone. So you can just call the function. And yeah. So the next thing we're going to talk about is the random module. So Python random is very, very helpful when we want to like maybe like create like card games or sort of like any sort of like game that requires some sort of, I guess, like initial setup or like random situation starting. Also very good for like a random number generator or anything like that. So we have a couple of methods. So first we have random.random. So this is kind of like basic random function. And what an interesting thing is, it returns a random floating number between 0 and 1. So what this means is that you're only ever going to get a number between like 0 and 1. So like, let's say, what if I wanted to generate a number between like 0 and 10? What I would have to do is I would say like, import random. We'll just delete this for now. So what I would do, let's say I want like a number between 0 and 10. I would do like x equals random.random times 10. So then if I print it out now, gotta print it, print x, and see now I can get a bigger number, but like let's say I get rid of this, I'll get, this is not a very good illustration, give me a second. Let's just say like x times 10, sort of like break it down a little bit here. So, I should probably print x as well. Give me a second. So yeah, like multiplying it by 10 will give us the range. So like, say I wanted to get a number between 0 and like, maybe not 10, like not a multiple 10, because I think that's like convenient for seeing the decimal point just move. Let's say like 0 to 13. Like, multiply this. And so that's all you do. You just like times 13, and then you can see like 98 over 1, that's about like 12.8 like ish over 13. Like that makes sense. And yeah, so then we also have random.randint. So if you only want integers, you can use this. And the nice thing about random.randint is it doesn't constrain you to 0 and 1 only. It'll return an integer number between like a specified range. So for example, let's say I have like random.randint 5 to 13. So it'll return a number between 5 and 13 inclusive, so like 6. And then our last method, random.shuffle, that we'll like cover, is what this does is more for like lists. So it'll take a sequence or like an iterable data structure. We'll talk more about that later. But it'll take a sequence and it'll reorganize the order of the items. So like it doesn't generate like a new value for you per se. It just shuffles what you have here. So like hi, bye, hello, goodbye becomes hi, hello, bye, goodbye. Or like any sort of permutation of this. Okay. So finally, we're going to talk about ASCII, so American Standard Code for Information Interchange. It's very long, so we call it ASCII. It's a common character encoding method for text data in computers. So this is sort of the chart. We have first the decimal number. So we often will use the decimal number, and then the ASCII code is sort of like the character, or like what your actual like letter or character is. And yeah, so we use the functions ord and char, or I don't know how you pronounce that, chr, to convert to and from ASCII from like, I believe it's decimal. So ord will give you an integer from the Unicode character that you input. So your input is a letter, and your output is a number. And when you look at ORD and CHAR, how I remember how I distinguish them is that they tell you what the output will be. So like ORD returns an ordinal number, CHAR returns a character. This should be a CHR. Yeah. But for example, like the first one we said was like ORD A65. So like go to here, A65, that's our decimal number. Oh, whoops. Same thing, like if we look at this should be CHR. But let's say like we look at 65, it does the opposite, gives us A back, so it's kind of it. And these are like both strings, these are integers. And yeah, that's pretty much all the slides.